Welcome to another video. In this video, we are going to talk about subnets in a very simplified and mathematical way. So to begin with, a subnet is a logical division of an IP network into smaller manageable parts. It helps organize devices, improve performance, and enhance security within a network. Subnetting uses a subnet mask to determine which portion of an IP address identifies the network and which identifies the host. So in general, you just have to remember this bullet point that subnet means a division of network into smaller, manageable, and secured parts. Next ahead, here consider an example. Let's assume that this is a warehouse or a network, and inside network there are these boxes which are racks, or in network terms devices with an address or an IP address. And then on the right side you can see this is the address of the network or address of the warehouse, or the gateway address as we call in more Cisco terms. And let's say I want to send some information to this network, or I want to reach a rack inside this warehouse. So my request is going to go inside the network. For example, if I want to go or reach this rack, I am all inside the network, and there are all the other racks which I can see in order to reach the one which I need. On the other hand, if we use subnets, you can see that the network address is the same, but inside the network or inside the warehouse, there are 4 segments. And if I want to reach a rack or a device inside the second subnet, my request is, or my sent packets are only going towards that address inside that subnet. It keeps every segment isolated and every IP address within its respective subnet. So if I want to send something to first subnet, my information only reaches the first subnet and the IP belonging to the first subnet as compared to the other ones. Next ahead, you have to understand network classes. So it is a division of networks in A, B, and C category. A network C, for example, has an address as 192.168, which is used for smaller or average networks, such as your house. Then there is class B network, which usually starts from 172, and the class A network, which starts from 10. CIDR notation is a method to represent IP address with a suffix indicating network size. So we will look into CIDR notation in more detail ahead. A subnet mask, a number that separates the network part from the host part of an IP address. For example, 255.255.255.0 corresponds to the CIDR notation /24. Similarly, there is broadcast address, the last address in a subnet used to send data to all devices in that network. Example 192.168.1.255 is the broadcast address for the network 192.168.1.0. /24 is the CIDR notation once again. So we will look into more detail in these terminologies once we apply the mathematical part of this video. So here you can see the power of 2 table. For example, 2 raised power 0 is 1, 2 raised power 1 is 2, 2 raised power 2 is 4, and so on until 2 raised power 8 is 256. That's the maximum one which we are generally going to need. As you know that the computer works in binary, especially the networks, so that's why it is 2 raised power and not any other number. So let's assume that there is a network 192.168.1.0, and we want to divide this network into 4 subnets. Let's put it on the side. So we know that default CIDR notation of class C network is /24, and if you saw the previous definition, the /24 CIDR notation corresponds to the subnet mask of 255.255.255.0. So this is the information which is just the default information which we know just by looking at the network address. And if we convert this /24 into binary, it's going to be 8 24s, and the rest are going to be zeros. And since a class 4 network has 4 segments, so you can see that it's for 4 segments, and the first 3 segments have 8 ones, and that last one has 8 zeros. So we just wrote /24 into binary notation format. Now we need 4 segments, and we can see that 2 raised power 2 is equal to 4. So which means there is something to do with 2 raised power 2. So let's write it down. 2 raised power 2 is equal to 4, and we need 4 subnets, and we cannot have 3 subnets. We always have to follow the order of the 2 raised power. So this information that 2 raised power 2 is 4 gives us the information that we need to borrow 2 more bits, because it was 2 raised power 2, we raised the power 2, that means that we need 2 more bits. So it means that we are going to change these two zeros in the last segment in order to be 1, because we are borrowing 2 more bits. That means we are just going to change them. So a new binary is equal to new binary of CIDR notation is going to be 8 times 1.8 times 1.8 times 1.2 times 1, and rest are going to be 0 because there must be 8 digits and we have to fill the segment. Now let's just clean this a bit. Here you can see, by the way, the 2, we needed 2 more bits, so we changed the 2 zeros into 2 ones. Let's just clean this a bit. I have organized the board a little bit. So what we did so far, we borrowed bits. We borrowed 2 bits, as 2 raised to power 2 was 4 and we needed 4 segments. And then based on this information, we discovered that the new CIDR notation is going to be /26, as 24 plus 2. 24 was the original CIDR notation. We borrowed 2 bits, so it's plus 2. It's equal to 26, which means our binary representation of the CIDR notation must have 26 ones. Now the new subnet mask is going to be 255.255.255. The last one is going to be different because now we changed the binary digits of the last segment, and we know that the value of the first one here is 128 and the second one here is 64. So 128 plus 64 is equal to 192. To know this, you have to look at that 2 tables, 2 to raise power tables, to understand that if you can see the position of the 1, so it is at the 8th position and we have to raise 2 to power 7. Why 7? Because we start counting from 0. Here, for example, you can see that I have written the binary notation of our network, and I have classified their positions. There are 8 segments, and in each segment we start counting from the last digit backwards or right to left all the way to the first digit. So the last digit's position is 0, the next one is 1, the next one is 2, all the way to 7. As I said, there are 8 digits in a segment. In the next segment, we start from 0 again. And their classification, their position inside their segment determines what is the power of 2 which we are going to raise. So in the last segment, you can see that we converted 2 bits, the first 2 bits of the last segment, and the position of the first bit is 7th. It's classified as 7. So 2 raised 7, which was 128. And the next bit is classified as 6th position. So we raised 2 to power 6, which is equal to 64. And we raised that the value of this CIDR notation, that this segment of the CIDR notation is 192. Similarly, if you consider the rest of the 3 segments, the first, second, and third, all of them are ones. And you can see their classified position 0 to 7. For example, the first one you can see, so it's going to be 2 to raise power 7 plus 2 to raise power 6 plus 2 to raise power 5 all the way to 0, which brings us to 255. So this is the origin. This is where the subnet thing of 255.255 came from. I hope this example broke the concept down for you in a very distinguished and proper way. Similarly, we can easily calculate that how many hosts are we going to have in the subnet. We have to see the value of the last bit. So the last bit which we converted was the second one in the 4th segment of this CIDR notation, and the value of the second digit or the second number was 64, as you can see there on the top as well, because 2 to raised power 6 is equal to 64. So we are going to just make -2. This is the general rule, -2. We take out the address of the broadcast and address of the network, which leaves us with 62, which means there must be 62 addresses available in each segment. Now, the next thing is the magic number, which is equal to 64. Once again, the value of the last bit inside the segment which we converted, and it is 64. As I mentioned, 2 to raise power 6 is equal to 64. So each subnet is equal to plus 64. For example, the first address of the network address of the first subnet is going to be 192.168.0. So plus 64 is going to be the next subnet, plus 64 is going to be the next subnet. And broadcast address is going to be the next segment minus 1. So let me just write down here in the table form. The first subnet is 192.168.1.0. The next one is 1.64. The next one is 1.28. The next one is 1.92, because we added plus 64 each time until we reached the 4 subnets. So broadcast address is the next one, minus 1. So 64 minus 1, 63, 128 minus 1, 127, and 192 minus 1, 191. The last one is 255, because in any case, when we reach the last broadcast address, it is always going to be 255. We don't need to do minus 1. So IP range means how many addresses are available inside the network. So in the first segment, we have 1.12.62, because 0 is reserved for the network, 63 is reserved for the broadcast. Similarly, we are going to apply this to all the rest of the subnet ranges. So these are the IP ranges in each segment. The second one, for example, 0.65 to 126, because 64 is reserved for the subnet and 127 is reserved for the broadcast address. So I hope you liked the video. I tried to simplify it. Please leave a like, comment, and subscribe to the channel. Thank you for watching the video.